guys, welcome to my class Karate DSL from Zero to Hero. And in this lesson, we will talk about what is API, what are API methods, request and response code, what is the client-server applications, and why do we actually need to test API. If you are already familiar with these basics, you can move forward. But if you are new to API testing, please stay here because you definitely should have a clear understanding of these basics. So moving on. What is API? API stands for Application Programming Interface. So it's a certain application which has a REST endpoint, and it's kind of a black box. And you can send the requests to this black box, and this black box will provide you the response. So we can name it like that. So let's assume we have a weather API that we know that can return us some weather forecast based on the city that we provide. So for example, we send the request to this weather API with city name. This is our JSON, city name in New York. And the API returns us response with current temperature, humidity, and forecast for 2 days. This is a very basic example, an idea of how API works. What are the type of API requests? It can be get, post, put, and delete. Get method is needed to request a specific data from API. Post and put method are needed to send data to API to create or update resource. And delete method removes the specified resource. Typical API request consists of API URL. This is HTTP link, and usually this link called as endpoint. Then you need to provide the headers of your request. Usually it's a content type of your message and or authorization token. Then you have to provide the method. Get, post, put, or delete. These 4 methods are more common. And you have to provide body. It's a JSON object with requested data. For the get and delete requests, you don't need body. You just need API URL with parameters. But for the post and put, you're required to have the body in the request. So what are possible HTTP response status codes? When you make a request, you have a certain response from the server with status code. And this code can tell you a lot about the result of your request. So when you have 200 codes like 200, 201, 204, and so on, it means that your request was successful and your API was able to process your request successfully. 300 codes, 300, 301, 302, means redirection, that API returned you redirect URL, and then your client should do something with this redirect URL. For example, follow this URL afterwards. 400 error, 400, 401, 404, and so on, it means it's a client error. It means that you made your request to your API, but something was wrong with this request. You either provided not correct request body, or your authorization header was wrong, or something like that. So it's the error on your side. And if you see the 400 error, you have to search the problem on your side. If you are doing this from Postman and C400, then it means something was not correct with your Postman settings. It's not the server problem. It's something with configuration on your side. Your request was not correct. And if you see 500 errors like 500, 501, 502, it means it was a server error. So your request was successful. API accepted your request, but for some reason was not able to process this request. So in this case, you will need to look into the server logs and trying to find out what happened over there. So this is the typical example of client-server application. In this example, web browser is a client and API is a server. And when you do certain operations on your web browser, your browser is actually sending requests to your API, getting data back, and this process repeats again and again. So most of the modern applications working like that. So let's look at very typical example, what is happening in the background when on your web browser you have this, for example, simple username and password field. So you type username and password, John123, and password Karate1. Then you click on login button, and right after that, our browser sending API request to our server with this information. So we see the body username John and password Karate123. Then our server is processing this request, and if the request was fine and server was able successfully to process this request, it provides response with status code 200, and we have a response body with first name John, last name Smith, age 35, and some, let's say, access token. And our browser then display, welcome John Smith, your age is 35. So this is very typical and simple example how actually client-server application works. How is it sending data to API and how it's processing the response from the API. Why do we need to test the APIs? To verify that API follows defined contract and the logic of the API is matching the expected result. So what is actually a contract? Contract is a kind of agreement between front-end and back-end or client and server on what kind of valid request server can get and what kind of valid response for this request server should provide. And usually this contract may look like this. So valid request would be username and password that should be type of string, and valid response should be an object with first name, last name, access token, which should be a string, and H should be a number. But what will happen, for example, if a backend developer will break this contract and will not provide the valid response that client is actually expecting? So this is example number one. Let's say we made the request and the server provide the response and the first name is null. In this case, our browser will not be able to display the first name. It will be just welcome Smith, your age is 35, because first name is null. Let's say another example, something like that. Then we have the age of 35, but it's not a number, it's actually a string. And our client is expecting number, not a string. So it's not able to process the string type. And this is why we can see something like that. Your age is, and possible error or null or something weird can be there. Or we can have even a more catastrophic scenario when we make a request, we got the response, and our response do not have access token. And this is a required parameter for our web browser to make a next request. And we can see some catastrophic error on the web browser. That is why it's very important to verify this integration that client and server follow the same contract. Usually in functional end-to-end testing, we have 3 building blocks. So we have our automation framework, which is Selenium or Cypress. We have a web browser and we have our API server. And what is happening here in UI automation, our framework making some interaction with web browser calling API provide response to the web browser, and in the framework we are doing verification is everything was fine, and we are continuing this process again and again. And this kind of testing is actually a valid and very good kind of testing, because if our web browser displays everything what we expect, if it works as expected from the user behavior, then most likely our API works fine as well. And we actually don't need any other testing or any other layer of testing for API separately. But there is one big disadvantage of this kind of approach. It's very, very slow. Sometimes UI tests may take minutes, or for big automation suites, it can be hours. And of course, developers not often can wait for so long time. For example, if they need to make a small change into the API and they need quickly to test this and to run a regression to verify that everything is working, they cannot wait for a few hours to confirm that. That's why we have an API testing. And in API automation, we replace our web browser with automation framework. In this example, it will be Karate, or we can use a Postman tool. So with API automation framework, we are creating simulation of our browser behavior and making the API calls instead of the browser and doing something like that. So we make a request to API, getting the response, and we are making verification of the contract and verification of the values that API provides. And the benefit of that, it is lightning speed. It's very, very fast. And also I remind you that Karate supports parallel execution, so you can run your entire regression suite within even seconds and get almost immediate response that your API works as expected. So in this class, we will learn how to make this kind of API automation to simulate browser behavior and to run our tests, and of course in parallel as well. So quick summary of this section. API stands for Application Programming Interface. The typical method types are get, post, put, and delete. Typical request has URL, headers, request type, and body. Status codes are 200 for success, 300 for redirect, 400 for client error, F500 for server error. The purpose of API automation is to verify that API follows the defined contract, and the logic of the API is matching the expected result. API automated tests are much faster than UI automation and can provide the almost immediate result on your regression test run. Alright, thank you guys, and see you in the next lesson.